Hello, hello. Welcome to the Strategy of Finance podcast. In a special episode today, we aren't necessarily celebrating a finance professional. Rather, we are going to unpack a topic for the community that's on everyone's mind. Yes, I'm talking about artificial intelligence or AI. Joining me today is a builder in the space, Joshi, founder and CEO of DAO Studio. Let's dive in. Harsh, welcome to the show.
Thanks for having me.
Why don't we kick it off with understanding who is Harsh Joshi?
Harsh Joshi has been in the AI space for over a decade now. I did my bachelor's in electronics communication engineering, did a small diploma on remote sensing and satellite navigation. I spent about 2 years working with Indian Council of Agriculture Research and a bunch of NGOs building drone systems to solve saline line problem. And then I kind of started building this technology at a startup called Smart Juice with Arjun and built a team where we were primarily using AI, IoT, cloud, all these technologies to save energy in HVAC systems primarily. After that, I spent a couple of years doing consulting, did product management for this startup called Zenoti. It's a SaaS startup in wellness space. After that, I kind of took a plunge on entrepreneurship and built my first startup called Sachet. It tanked, it tanked really hard. But the idea over there was also pretty much around AI. We were trying to uh, build a model, actually built a 7,500 parameter model to gather all the crime related data, to analyze sensor data, and in a nutshell, to predict the false positive rate on these 112 call systems, right? Because in India, first responders to civilian ratio is 1 is to 1.5 lakh, right? So you really don't have a lot of first responders for every civilians. And if you have all of these false positives coming up on these emergency lines, that's a problem. And that's what we try to tackle. Couldn't really commercialize the technology, so we started something else. That's how we came about building DAO Studio. And right now we are building this product called YOJN at DAO Studio, which tackles some of the key challenges in the AI space and helps startup get from demo to production.
All right, quite interesting. When did you first caught a bug? Well, I guess I'm talking to engineers. I can't really talk about bugs. When did you first get inflicted by the whole enigma around artificial intelligence? What was the first introduction?
I think I was back in class eighth. So my cousin brother, he was studying at this college in India, BITS Pilani. He was a electronics major, and he used to come back during summer vacations. I used to bring all of these books and all of these video lectures on this LAN system they used to have. I used to read them. I was building websites and all those things, and the idea of making everything into some if then else routine writing program wasn't really a fun thing. I was like, can't these systems learn for themselves? And that was the first, I think around class 8th, class ninth, I got into this whole idea of let's build something in AI. And since then, I've been just carrying that thing forward.
You mentioned in your introduction where you worked at Smart Jewels and other places. There seemed to be a good combination of hardware, software. Sensors are in place, and then they are learning and doing something. Software is in place, and that's learning and doing something.
Yeah.
Is it a field which actually brings back software and hardware in some ways in reality and like unlocks IoT in a truest sense, or you think it was just serendipitous into kind of how you got exposed to that hardware plus software kind of field and just kind of made it work?
So, I mean, the whole idea of thinking hardware separate, software separate, it doesn't really make sense, right? When you're talking about artificial intelligence, because in the end, what is AI? You're trying to make a system learn certain behaviors, and you want it to behave in certain way and then give an output in that way. So it's always response, and then like there's a certain stimulus, and then you respond to that stimulus. So that stimulus can come in from any way, right? It could be a digital stimulus, it could be a sensor data, it could be a motion actuator, like your pressure sensor sends something. Or it could also be like just your click through rate or something like that, right? It could be anything. It's a stimulus in the end. And then you respond again depending on what problem you're trying to solve. Either you respond by moving a motor, or you'll respond by kind of showing certain pixels in certain ways, or you'll kind of respond in showing a graph or whatever. The idea of hardware being very different from software doesn't really work, because in the end, even your software works on a hardware. It's just not a mobile hardware, right? In the end, that's what your software also is. There's nothing magical when you talk about cloud. It's someone else's computer, huge data centers rack somewhere. So it's still a physical hardware in the end.
Makes a ton of sense. Yeah, it's an input-output device at the end of the day. Okay. Well, why don't we dive into kind of some AI 101 stuff, right? So let's start from the kind of the highest level question. What is artificial intelligence? What is AI?
I mean, there's no one right answer for AI, because at this point, AI is more of a marketing term, right? But if you really have to think about it, let's say you have a process, right? And you have 100 rules around it. If this is happening, then do this. If this is happening, do that. Arguably, if you can write that if then else routines, that's also an AI, right? The challenge with that is it doesn't really scale well. And prior to 1990s, that's how most AI system actually worked, right? There are different fancy ways to do that, but in the end, these are if then else systems. And then a lot of smart people started thinking, can these systems self-learn? And that's when you saw this emergence of complete class of algorithms, which people started calling machine learning algorithms, right? Wherein you had these models come up like decision trees. Now, the thing with decision trees was these systems are highly interpretable, right? But again, they don't scale well, they don't generalize well. So the AI systems that are all the rage today that do really scale well and generalize to a problem really well, these are neural networks per se. And at its root, what these systems are doing, they are just function approximators, right? So think of it this way, like in finance, like you used to seeing a lot of data in Excel, and you're seeing revenue growth, this growth, that growth, and you're trying to plot a trend line through that. And based on that trend, you're trying to make a prediction. Okay, X years down the line, how will this company or asset behave? That's what these machine learning systems are doing. Like neural network is a function approximator. You throw a arbitrary data to this model, it tries to form a decision boundary around it, and then based on this boundary, it is trying to make a decision. So when they form this boundary, that is the process of learning. They've learned the spread of this data.
That, let's say I have finance, right? I have some accounting rules. It's very defined, right? Um, there are probably 100 different textbooks that can be best of breed in accounting, and they'll say more or less all the same thing, right?
Yeah.
If we fed that into a system, it's not going to auto learn, right? It's not going to understand the boundaries. It's not going to understand how to behave, what to behave. What is it? Is it just basically providing it with the rules to work with? Is it that simple?
So, like I said, there are two approaches to it, right? The older ways are way more interpretable, right? As in you, but that actually requires a lot of effort, and that hence it does not scale well and generalize well. Where you read this book and say, "Oh, these are my rules. Now I'll encode these rules in certain way," right? You're manually doing that. That's a more interpretable technique, but it does not scale really well because there are infinite rules. Now, how many rules are you going to encode, right? And then there's this new class of system which is not really new, like they've existed for a while, but now only they've started becoming like mainstream front and center everywhere, right? These neural networks where they essentially you don't encode each and every rule, you give all of these data and then you give certain instructions on, or I would say examples on, if I ask this question you should answer it like that. And then these systems try to understand what is this general rule going on inside of these books that I can probably learn. It's kind of like how you build an intuition around a subject when you study it really well, practice it multiple times, and you kind of get the intuition, oh, I don't need to summarize all these jargons and learn it. Essentially, this is the trend that I want to analyze. So that's what these systems are trying to do.
That sounds quite magical. That all the learnings that a person may have by, let's say, reading a certain number of text, a certain amount of text, and then being able to work on it for a number of years, a system can just learn it and is able to answer those questions in not that long a time frame. You mentioned a few words there: machine learning, this, then that. Maybe you can call it more like a rule-based systems or AI, neural network. There's a term, of course, like Gen AI. Are they all the same? How are they different? Can you make some alignment around these maybe four or other similar words that are around this ecosystem?
Sure. I think it's better understood through certain examples, right? Machine learning, neural network, these are just like different forms of the same thing. We're talking about making systems intelligent, right? And over the last 2 decades, you really saw a commercialization to the point of near perfection of these technologies, right? So, for example, when your system, a piece of code in some software is trying to say that, hey, this person has marked these kind of mails as spam, I'll mark this mail also as a spam until he tells me otherwise. That's also machine learning happening, right? And that happens in your email systems every day. Or let's say, hey, this person is buying these things. I should show him this product with this much discount. There's a probability he'll buy that also, right? Amazon. That's also machine learning happening. Machine learning is just a class of algorithms, right? And there are different kind of problems you solve through it. Like there's a classification problem, there's a regression problem. Latest in the most praised about things is generational problems, where these systems can also generate text, not just classify or label them, right? So AI is like a broad field, and there are different ways to do that. But the scalable systems are not rule-based expert systems. These are more machine learning algorithms. Inside of these machine learning algorithms, there are different kinds of algorithms. One such category of algorithms is called neural networks. It's essentially a piece of code that mimics how your brain works, and it is one of the most general function approximators on this planet, right? The problem is it's really opaque. You don't understand why it has formed those rules. You only understand how you taught it to get to that point. And these are two very different things. So all the craze that you see today is because these, what really happened over the past 5 6 years, there was a race to, okay, let's start making the system as big as possible. If you're making a neural network, can I make it this big? Can I make it like 100 parameters long? Can I make 100 billion parameter size, right? So you're constantly increasing the dimensionality of this data it can comprehend and the parameter it has to analyze. They're making it bigger and bigger, and that's what gave birth to this idea of large language model. So it's essentially a language model, but it's like a really large system. Or prior to that, for imaging system, you had deep convolutional neural networks, right? So these are different classes of algorithms. And this was so one of the systems that are all the craze these days, right? GPTs and LLMs. These were primarily, I would say, pioneered by Google, right? Around 2016, 2017, based on these BERT kind of architectures. But what really happened was OpenAI actually drove it to home, right? They said, okay, I'm going to pre-train it with lots of data. I'm going to do lots of QA around it, and I'm going to just optimize each and everything that I can around it. And that's what gave this one very special model that just exploded after 2022, which was GPT, generative model, which is a pre-trained and a transformer architecture. So it's just the same thing, but in different form. But everything's a bit more nuanced if you go into the technicality.
Got it. So we'll unpack GPT a little more, but before that, some people are calling this whole sort of Gen AI revolution as a 70 years overnight success. Is it because the first sort of neural network paper came out that long back, and it just took 70 years for it to get to a place where it can be commercialized and people can start using it?
So yeah, I mean, like if you look at the very oldest systems, right? Most of these systems were actually these papers were published back in even 1950s, right? So it's definitely a 70-year long overnight success. But if you really look at the history of adoption, around 1990s, you had first convolution neural network that were running. This one OG of this field, Professor Jan LeCun, right, who heads Meta AI Lab. So he at Bell Laboratory actually demonstrated digit and character classification using CNNs back in 1990s. The whole idea was these machines require a lot of compute and a lot of data. So you could arguably say most of these technologies were way ahead of its time because the infrastructure to power these technologies was not there, right? Now, the past 2 decades, you saw the emergence of this whole cloud phenomena. Anyone and everyone was building anything using cloud only. So you had these things like big data and all of these fancy terms came about. What they're essentially talking about is you're taking data, you're storing it in different place, you're trying to distribute because all of this data cannot be stored in one place. So there are different techniques around that. Now, how fast can you process it and how efficiently can you process it and how systematically can you manage this data kind of gives a direct throughput to the raw firepower you can put inside of these models. And that's what really started happening. And over the last 5 6 years, what we have seen is these systems now, on one side the technology has evolved, the other side the research has also evolved to a point, yes, maybe we can start putting them in any and every place we can imagine. But I wouldn't say it's still a success because there's a long road ahead. There are a lot of challenges. Cloud and software engineering primarily had multiple decades to evolve. AI has not yet had that decade. It just went from research to production overnight, particularly when you talk about generative.
Makes sense. Let's talk about LLMs a little bit. As you said, the large language models. What does that really mean? Can you give us some flavor of what defines large, what defines language, and what does this kind of model really mean and is able to do? Because you told me before the show that in some ways it's just two files, right? But it's crazy to think about a model as just two files and it does so many things.
Yeah. So, arguably, there are two things, right? One thing is you providing raw energy, that is raw data that you want to process. And the second thing is you are trying to approximate what this data is trying to tell you, right? Forming decision boundaries inside of this data, forming a curve through your Excel data sheet, right? These are two things. So there's an algorithm and then there's this data. And once that decision boundary is formed, it is stored in this format which you call weights of these neural networks. So in the end, it's weight and your algorithm that can generate these weights or interpret these weights. That's it. So what's happening inside of these, and see, the large is again a marketing term more than a scientific term because there's really no hard definition of it. Like 1 billion parameter is that large, or like 100 billion parameter is that large, or like trillion parameter is then when you really say it's large. So again, it's very marketing and hazy boundary around large. But the idea is, yes, we're talking in the order of magnitude of billions of parameters. That's the general concept.
What does that mean? 1 billion parameter versus 100 billion parameter, what's the difference?
So, depending on the technique on how you've trained it, the definition may vary. But if you simply look at it, right, you want to analyze revenue versus sales kind of a graph, right? So, essentially, dealing with only these two parameters around which you're trying to form a trend line. And I was saying, no, I also want to study it based on the segment of the company it is. Like I want to study SaaS companies revenue versus years, and I also want to study how does that behave if it's not a SaaS company, right? So essentially what you're trying to do is you're trying to add more and more dimensions to the data, right? That you're trying to interpret. But depending on the technique, most of the time these parameters are not directly your headers. Sometimes these are principal components, and so there's a lot of science to it. But on a outline level, yes, you're trying to study how many combinations and permutations can actually represent this data, so that I can get a better, bigger picture of this data. That's in a nutshell what's happening. So when we talk about language models, so GPT is one of the most famous, like everyone knows GPT, right? And what powers inside it is like this Da Vinci model that used to be there. So what these models are actually doing, right? These are sequence to sequence encoders in the end. So for example, you gave a prompt and ChatGPT gave you like a really fancy essay on that prompt. So the sequence of tokens that got translated to another sequence of tokens. tokens are just like words. Only thing is, in literature, when you say it is a boy, so these are different words. But there are certain permutations that can be arranged around it. And again, that's a whole field of how do you tokenize things better and what efficiency can you drive with those things. But the closest counterpart you would say is a word, right? So these systems, they are really large in size. And why they're large in size? Because they're trained on really large amounts of data. And these are sequencing encoders, so they have really good understanding of how these words come after each other, the sequence of words. So that's a ballpark of what these large language models are doing. But again, this is all very high level. There's very much subtleties and details to each and every of those terms.
Makes sense. So there are these GPTs or more language oriented models, which one can say are made more famous by OpenAI's Chat GPT product, right? And then there are other products in the market which are doing image generation or video generation, right? By just taking a text prompt from the user. The models behind them are called diffusion models. Is that right?
Yeah.
So what's a diffusion model? How is that different than a GPT or an LLM?
So, I mean, think of it this way, right? Let's talk about finance for an analogy, right? So, you want to get to the valuation of a company. So, there are different ways to do it, right? There's discounted cash flow method, there's net asset value. So, to do one thing, there are multiple ways, right? And each way actually is not just, okay, I have different ways to do one thing, but each way gives you insight into a certain dimension of that problem, right? You understand it better from that aspect. So similarly, these are different approaches to building these neural networks and solving these problems, right? Some of them work really well for image-based problems, right? So diffusion models is one of those approaches where essentially there are two processes, right? And one process essentially just focuses on generating image and trying to identify if it's the right image or not. The second process is trying to add noise and trying to figure out what is the distinction between these two things. So one's trying to confuse the other is trying to beat it, and it's an eternal loop. And the output is still the, like, you want to run this loop to the point where a human understanding of this image is good enough. So, for example, about 5-6 years back, we had these tools. Google released it called Deep Dream models. They were also doing the same thing that these diffusion models are doing today. Only thing was they were not that good, right? Because the definition of quality is really subjective, right, for an image. Now these systems have been perfected and fine-tuned to the extent that what they are generating is just like blowing people away, right? So it's a different approach. It comes from this primarily one class of architecture called generative adversarial networks, or GANs, which were again pointed way back, like 2006, before and onwards of 2016. The only idea is now they have gotten to a point with the amount of investment, capital, fine tuning, and advancement, and resources and technology, that it's acceptable. The generation output quality is better.
Got it. Interesting. You mentioned the pre-training with the GPT models, right? That's what the P stands for. Then you mentioned something around fine-tuning, right? And then there is another word which is somewhat relative, which is RAG, right?
Yeah.
Can you unpack these three, how they're similar, different, interrelated?
So RAG is a very different kind of a thing, right? Let's first talk about pre-training and fine-tuning. So again, the way to understand this is when you start from scratch, you're kind of training a model, right? Pre-training. But once you've trained it enough, now you just want to give it a special spin. Think of it this way: you've done your bachelor's, now you know engineering. Now you just want to get really good at software engineering, so you do masters in software engineering, kind of thing. So when you want to give a special flair or kind of train it for one specific purpose without discarding all that previous knowledge mass that you've done, so that's the whole idea of fine tuning. So it's that 80-20 rule in play, arguably based on the technique. Sometimes in fine tuning also you go really deep, sometimes you really don't go beyond one layer. But again, more of marketing concepts, but technically it depends on to how to what depth of this model you are going to train it. And arguably in pre-training, you're starting from scratch, so you're training everything. So that's the difference. And fine tuning and training, there are a lot of algorithms, there are a lot of techniques, well defined techniques, right, to solve it. But to a certain extent, it's an art because you throw certain kind of data at the problem, you twist certain parameters, you instruct it to behave in certain way, you use different kinds of algorithm, you observe this happened this way, it should have gone this way. Then you go back, change those parameters. So it's more of an art. You're sculpting the model, ki, hey, behave it this particular way only. While there are techniques, but it's more of a art. When you talk about RAGs, that's a completely different area. But so think of
So we'll
RAG.
come to RAG. So on the pre-training versus fine-tuning, you talked about it being an art and it being an 80-20 thing. So arguably what you're saying is basically LLMs are generic in nature. They are built by these few companies to be used at as large a scale as possible. And then whoever is ultimately using them for, I would imagine, business purposes can then use fine tuning to really make that LLM a lot more customized for their own purposes.
Yeah,
Is that the right way to think about it?
that's a right.
Okay. If I have, well, I guess then the question again comes around the large language. Where I was going was, if I have enough data, can't I just have my own LLM? Or I guess there is a term called SLM, small language models, that are also being thrown around. Are those kind of basically that I have enough data and I could just train my own model from scratch?
So when you talk about SLMs, LLMs, like I said, these are mostly marketing words, right? They don't have like a lot of technical resemblance. It's a scale, right? How many parameters do you want the system to train on? How many layers do you want this model to have? How dense this network should be or not, right? So it's one of those things. So the point here is, if you have your own data, can you create your own model? The answer is yes, you can create. Question is, should you create it? That depends on a lot of factors, right? Can you create it? Yes, you create it. The point is, there are a lot of subtle connections these networks form that today we don't really understand why exactly. The community is split, debating, there's futurism, there's doomerism, there's different schools of thought and all that. But if you cut through the noise, essentially the entire community has consensus that we don't really understand how these connections are being formed in a deterministic way, as in can be predicted before these connections have happened, right? So because of that, there are a lot of new interesting properties that arise. So for example, if you have a model that's trained on a corpus of a lot of language data, so arguably it has gotten really good at grammar. Now let's say you have your own customer support data and you want to fine tune it for customer support data. You don't need to teach a model grammar, right? So that's the point of, should you pre-train it or should you fine tune it? It really depends on the use case. Do you want to do all of that work? Is the question. Can you do it? Yes. The answer is always yes to these things. If you have enough money and if you have enough compute and talent, you can do anything you want. There's always a question, should you do it?
Got it. Makes sense. Why don't we now move to RAG, where I interrupted you while you were starting to explain?
So RAG is a very interesting area. And the way to understand it is the analogy is with software development world. So prior to this whole AI being front and center in all of these spaces, software engineering was the way to go about solving any of the problem you wanted to solve, right? And in software engineering, there's this fundamental concepts of operating systems, right? So these operating systems have two, three fundamental aspects. One is, okay, they'll control your hardware. They'll know when to call in this processor to process something, right? In RAGs or agentic systems, your LLMs or these models are that processor unit. That's it. Now, all of these operating systems have threads or processes. They are managing multiple processes at a given time, or maybe they are doing one by one. But these are different processes that are happening inside of a system, independent items, right? That can talk to each other. So in these new AI architectures, that's what your agentic systems enable. That's what these agents do, right? There are lots of agentic frameworks. That's essentially what these are doing. Now, inside of these traditional systems, you had memory where all this computation was happening, the data was being cached into, right? All of those areas. That's what context is of these models. In AI system, that's the context. Okay, this is the context window. How many tokens can I process at one given time? Which means not everything can fit into the context, right? So you have to bring certain things into the context time to time. That used to happen in software engineering with this concept of IO. That's what RAG enables in these modern AI architectures. So arguably, if you have a huge customer data set and then you have a really good AI system deployed, and your customer information is, let's say, terabytes, let's say, right, gigabytes. No model today will give you that context, right? So the best way, and you can't constantly keep on training your model on all of that data. So as I say is, okay, I'm gonna make sure my AI behaves in certain way, and whenever it needs it, I can go look it up from that table and get it for me. Right? That's the whole idea of RAG, retrieval augmented generation. I'm going to retrieve some information from some places, and then I'm going to augment my generational capacity of this AI through what I have written.
Got it. Can you share an example or two of where this RAG technique is being used today quite prominently?
So when you use ChatGPT, right, and when you ask it certain questions, you see it gives you sources, right? Hey, I found this article over here. So that's RAG happening in real time, right? Bing uses it, co-pilots, and even in your customer support systems. See, the first adoption we're seeing of generative AI is in customer support, right? In most of these areas, what's actually happening is it's going looking up your past invoices so that it can tell you, okay, what kind of refund should I enable to you or not, right? So when you have to look up something, you can't, because these data are constantly being refreshed. You can't keep training your system with all that data with the rate with this data is being refreshed. And neither can all of this data fit in the context window of your model, right? That means you need a separate pool of data. That's the tradition in software architecture. That was the job of databases and IO happening, input output from that data. That essential piece is being replaced by RAG in this AI architectures.
Quite interesting. Let's talk about prompt engineering now. I mean, there are even courses of prompt engineering. From a user's perspective, it seems like, hey, you're asking a question. The system should be intelligent enough to give you the answer that you intend to ask, even if you didn't ask it the right way. But in AI, it seems to make a hell lot of difference in the way you ask the question. You may get completely surprised by the quality of answer, either which way, right? So help us understand what exactly is prompt engineering. Is it the way the user is putting the request into the application, or is it something that is happening behind the scene?
The short answer is I feel prompt engineering is a field that's going to go away as fast as it has come. That's the short answer for it, right? And I'll tell you why. And there are different schools of thought to it, but for that we need to first understand how these AI systems actually operate, right? And when you see an image, right, you see, is it my nose or is it your nose, right? That's what you see. Is it my eye or your eye? That's not how AI system sees the world. For them, it's a matrix that describes intensity at a particular point in red, green, blue channel. So there are three matrix. So difference between your nose, my nose, and horse poof for a model is 0.01835, comma 231. That's how a model says. The model does not differentiate between my nose, your nose, or a horse poo. It just differentiates between these boundaries of these data points that are scattered across these spaces. And if the difference is good enough, it will just give you that output. That's the whole idea of vectorization and kind of breaking things into vector, because that's how a model internally represents data. It's studied in form of these vectors. Now, let's say your vector representation and all this data representation inside of this model and anywhere, right, in this latent space of where this model is thinking about, roaming about internally with all the training you've done, is really trained on certain, like there are certain vectors that are clumped together. There's certain areas that get activated on this word called markdown, because apparently in that corpus the word markdown table was used a lot. Now, when you are using this model and you're saying, hey, ChatGPT, give me a table of these three numbers, you might not get that same answer that you're expecting. But when you use the word hey ChatGPT, I want you to generate a markdown table for this particular data set. Something's going to happen, and that region inside the model is going to activate, and you're going to get that desired output, right? So what's essentially happening is you're just trying to guess which word is going to activate which kind of a behavior without actually knowing what kind of corpus that model was trained on. I mean, it's one of those beginner's luck kind of a thing, right? Your first guess will be good, and you might be in that gambler's fallacy kind of state. Yes, prompt engineering is doing some real damage. But in the end, till the time we really understand how these models behave and operate and control them, prompt engineering is not a sustainable way to solve these problems. And in most of these cases, prompt engineering is a hit or miss. So it's good to get started. It's good to play around with it. It's good to kind of generate the buzz and get people involved to contribute in AI. But me personally, I don't think prompt engineering actually moves any significant needle other than a hit or miss kind of a thing. Because it's not a scientific way to solve a problem. You really don't know what's happening inside this model, what's being acted.
Got it. You mentioned something around vector database, vector embeddings. What are those? What role do they play in this whole matrix?
Yeah, so like you said, right, in the end, these systems are number processors, right? Like as much as the illusion of them being sentient or intelligent or smart or whatever cool kids are calling it these days, you want to put it, but in the end, they are just processing numbers and how these numbers are grouped in this weird space, right? So in your Excels and in all of these finance data, you compare two numbers. So there's like X versus Y, and you're comparing one data with other data, right? That's what these models are doing. Every data that you give, either you give it a photo or an image or a document or a number or a sheet or an essay, everything essentially gets converted into the sequence of numbers that gets plotted in this high dimensional space somewhere. So it's this art of translating any data into the sequence of number. That's the whole job of embeddings. It is this vector space in which they get represented. So in your legacy databases, you have this idea of records, right? And you're storing things in either records and there are columns and how you're storing. So that's just a representation of things. For abstract data, the like image, how would you go about storing an image? Where would you place my nose and your ear inside of the same image in a database, right? So really smart people came up with these ideas of kind of creating these databases which vectorize this information, store it in this vector format somewhere, which is easy for a model to understand. Probably you might not be able to make sense out of it, but then you really don't have to make sense out of it. Your model needs to.
Interesting. Is it safe to say that what SQL was for structured data, these vector databases and these vector embeddings are for unstructured or abstract data?
Yeah, arguably that's a pretty sound analogy.
Okay.
All these analogies, right, depend on the audience. So, like, if you're talking to a business person or a product person, these analogies make sense. But if you make that direct comparison in front of a scientific community, they just be ready for torches to blow up.
All right. Makes sense. Let's talk about another term called AIOps or MLOps, right? That seem to think about composition of teams at times. It at times represent a certain number of tasks that people are doing that falls under it. But of course, given this is such an emergent discipline in itself, there is no sacrosanct way of saying what is MLOps, what is AIOps. Are they two different? Are they completely separate? So help us understand what, in your view, is MLOps or AIOps.
So, uh, I think the short answer is MLOps is the difference that between you calling your engineer to show a demo to your board members to your AI system being consumed daily by your customers and them actually really liking it. That's the short answer. Because what's really happening is these systems. So one part is the research problem. Okay, you solved it really good. And the other part is making a software out of it. Okay, you did that as well. But then comes the bigger problem, right? How do you distribute it? How do you scale it? There are a million people using it simultaneously, right? Then there come security issues, challenges around complexity, and the cost blows up. A lot of things happen, right? It's not just magical, right? It's not like your DevOps teams just kind of goes and drinks Red Bull and bibbidi bobbidi boom. Now system is live. They're actually doing some really interesting engineering to solve these challenges. So that entire class of problems that you solve to take these systems to production, that comes in this category of DevOps. Now DevOps was and still today is one of the key pillars of software engineering, particularly in the SaaS domain, right? Now with AI, the same problem needs to be solved, but in arguably very different ways, and a lot of these problems are unsolved. And so, for example, you don't have this notion of decomposability, controllability, explainability. There's a lot of segments that are still unsolved. So the whole area of AIOps is an evolving space because these things were taken for granted in software engineering world. And then over 2 decades, these technologies matured, solving those problems that were already solved, but distribution wise. Now in AI, you have to first solve those problems and then you have to again do the same work that DevOps did for the past 2 decades to get that to a maturity. So that whole evolving space is AIOps or MLOps or LLM ops. Again, jargons depend who you're talking.
So let's understand why an AI application is so different than a non-AI SaaS application. What is it that makes it uniquely challenging?
So there are lots of challenges, right? There's not a single challenge that you can point to. And all of these challenges come together to create a big chaos, right? So let's tackle them one by one. So in your legacy systems, right, you had this idea of decomposability. What it simply meant was, hey, I want to solve a problem. Let's create a software out of it. How will I create a software out of it? I'll create certain modules of these software. How will I create certain modules of this software? I'll go and create certain classes, certain functions inside of these modules. These are fundamental building blocks. Each block can be customized, programmed, and interacted with other elements. Right? You have this idea of decomposing a big problem into small problems.
So microservices, is that kind of what in the SaaS world one can say decomposability?
So see, the microservices like a very generic buzzword around a particular way of architecting SaaS systems on cloud. But the idea of decomposability runs really deep to the principles of even compiler design and so programming languages also. Right? It's a fundamental idea. Can you break things down into simple atomic blocks? That's not how AI works. Particularly these models that generalize really well but are not interpretable. I'm talking about neural networks. They are not decomposable, right? You cannot go to a model and say, I'll just talk to this particular neurons inside of this model. It doesn't happen. You either talk to a model or you don't talk to a model. That's it. It's 0, 1, end. So that decomposability is not there. Now, another thing is determinism is not there, right? So for example, in software engineering world, you had this idea, hey, I'm writing this function. This is supposed to return 2 plus 2 is equal to 4. This is an addition function. So I can test it. It has to go 2 plus 2 is equal to 4. Is it giving or not? There's certain amount of determinism because you know each line will behave in a certain way. Again, in AI, it's generating sequence, right? It's just trying to generate a sequence of tokens, at least the way you have AI today, which means you really don't know what's going to come out. There's only a certain probability of what might come out. So again, there's no determinism. How are you going to test the output? Because the output itself is not deterministic, right? So it's a chicken and egg problem. It's a loop over there. Now there's another challenge, right? Because these things were decomposable and deterministic, right? So you had these two really awesome things came out of it. They were controllable and explainable. You knew what your software was doing, right? And you could control it to do a very particular thing. Now, inside of these systems, you really don't know what's happening. So, you know how this architecture is designed. The community understands that really well. You know how you have trained it and what sort of data you have trained it on. You just don't know deterministically what part of this model will get activated when what kind of question is asked and what kind of output it may spit out. Right? So, that level of explainability and controllability lacks. This is a problem because we just got used to taking these ideas for granted, and then we built on top of it some really amazing technologies. A lot of smart people built a lot of cool technologies for the past couple of decades, but those principles don't directly apply to AI systems. So you have to kind of rethink from first principles a lot of problems. Hey, how do I go about solving this? Do I want my customer support agent to go tell my customer, you go fuck yourself, I'm not going to give you this receipt, right? It's not going to happen. How do I do a QA of these problems? So a lot of these things are still unsolved and the entire community is working. And each of these problems is an area on its own to solve for and a long road.
Got it. Are these the primary reasons also why businesses are still just scratching the surface with the adoption of AI? There's a lot of buzz. Of course, OpenAI has been fastest to cross a billion ARR and so on and so forth, right? For the right reasons, but again, that seems to me to be more focused on the personal usage or people trying it as a new magical tool that is in the market. Not businesses are adopting it at the largest of the scales, right? Where I could argue every single business could have some use of it, whether from a productivity side, cost reduction side, or revenue enhancement side. Right. And so maybe beyond these controllability, explainability, decomposability, are there other things that are stopping enterprises from adopting this new technology?
So, the short answer is, yeah, there are many. But like, if you really go deep into it, these are the fundamental problems. Everything else is a compound combination of it. So, for example, if you cannot control and if you cannot explain, that means you cannot do a good quality assurance. That means you don't know what you're throwing out in front of your customer. Or let's say, if you cannot decompose and if you cannot control, that means you cannot build that rich journeys around it. So, there are many problems. And if you cannot explain something, that means you cannot govern it. Like, you don't know what's happening. Like, the first step of governance is you better be able to explain something. Right? So what will your compliances do? Let's say you build something and the model behaved in a certain particular way. Who's liable for it? Company is liable for it, right? And the company is liable for an adverse effect. What does the company do to fix it? Right? So these are just permutations, combinations, and different manifestations of the problem. At its root, the fundamental problems that we described, as long as these are not solved, or at least solved significantly enough to be able to roll things out first, right? Because again, this will always be a chicken and egg. Without rolling things out, you will not know what to do better. But to roll things out, you need certain level of assurity, and so it's that loop where the whole industry is stuck in, which is why you saw like these consumer segments where this was not a mission critical application. This could not lead to any kind of financial loss. For example, hey, I'm just chatting with the chat assistant, right? What's the worst that can happen? There you saw adoption of Gen AI coming in, right? Now let's see insurance segment really drive it home with that level, right? The answer is it's not happening, right? At the root of it is these problems, because, and it's not like these segments don't use AI. For example, most of these hedge funds and all of these systems, they do use AI. And if you really go investigate the kind of AI these systems are using, they are using really old school systems, decision trees. Why? Because they're interpretable. They are not even, so your problem might have like millions of dimension, but the decision tree that gets deployed in production will at max have like 70 dimensions to capture, or 700, right? Why? Because it gets the job done and you know exactly how it will behave in a certain situation. So it's going to be a long road. It's not going to happen overnight.
God makes privacy is another thing that I think many businesses are struggling with to really put their arms around and say, okay, we can deploy XYZ AI solution amongst everything else. Privacy is taken care of, our data is secure. What do you think about that particular evolution of that side of AI systems?
Yeah, so arguably, privacy was always and is always going to be a problem, right? And will always be a problem. And for all the right reasons. I mean, you don't want your insurance company to find out key, let's say you ate two more samosas than usual yesterday, because if they have that data, they can arguably make a case around why I'll jack up your prices. So it's all for the good reasons, right? You need to protect certain kind of privacies around you. And as data is being more commonplace in the society, the technology is being more commonplace in the society, your need to actually rely on that data is increasing. Simultaneously, the awareness of the consumer around what that data really represents for me is also increasing, right? So these are two opposing forces that kind of push, like how these mountains are formed, right? One landmass hits another, and mountains are formed. So that's how privacy is becoming one of the biggest problems to solve for, and it should be. And again, like, you don't have determinism, you don't have explainability, all those things. So you really don't know once the data goes inside the model, how and where it's going to come out in which form. You don't know that, right? Which means if you don't know that, be careful what you're putting out in production.
Makes sense. Sometimes I wonder, with so many chat or text generation applications out there, people are generating content left, right, and center. There is perhaps going to be a time where the content that is getting generated is coming out of AI, and that content is being used to kind of train the AI systems of the future. Is that not going to create a garbage in, garbage out kind of a loop at the end of the day?
So the interesting thing is, we should be scared of it, right? Because at one point the kind of becomes like a self-fulfilling prophecy kind of things. You really don't want that kind of thing to happen, because uh, so there's this really interesting book called Moral Tribes. Okay, and it's written by a Harvard professor, and at its core it argues this one fundamental principle that humanity does not have an objective definition of morality today. It's a subjective thing. How do you expect these smart systems to have objective definition of something? You yourself don't have an objective definition of something. Four people have different definition. How would this model have, right? Which means the more data it gets trained on, it's just amplifying what's inside of it. So if there's a bias, it's going to get amplified. If there's a particular garbage, it's going to get amplified. Which means with these systems generating output, it's just amplifying that thing. And now again, you put that back into the training process. So you are creating a outcome that you have no control over. And there are a lot of techniques coming on. So it's not, arguably, this seems like a chaotic thing. But then there are a lot of smart people around the planet. There are a lot of smart mathematical techniques to filter through it. But there comes a question, to what extent can you solve it? And what better guardrails, policies, practices can be put? And some of these things will not be done by one government or one company. For example, like Bluetooth is a standard format. If every company had a definite definition of how to transmit that signal, no two devices would be able to communicate on Bluetooth. Some things will have to be standardized in the end. And it's all for the betterment of the whole ecosystem.
Okay, this is starting to make some sense now. So now there is OpenAI, right? There is Anthropic Claude. Google has some models. But then on the other end, these are more closed source models, right? And then on the other end, you have Mistral, Llama, and a bunch of others that are more open source models. Why is open source exploding on this whole AI thing? I mean, it was prevalent in the SaaS world. I would say a bunch of interesting projects, really seminal companies came out of that whole movement, but it was never so front and center in the conversation, right? I still remember when IBM bought Red Hat, it was a big deal, like a huge deal. Why a company like IBM is buying an open source company? Same thing around when Microsoft looked at GitHub, similar kind of a logic. What's so special this time where there seemed to be, maybe not from a commercial perspective yet, but at least from the pace of innovation perspective, the open source is kind of really keeping pace with the closed source community or models or whatever you want to call it on this whole AI trend?
So, I mean, part of this answer will be a speculation, of course. But I don't think Llama or Mistral or any of these open source systems being run by big corporates. is being done for a social benefit scheme. Right? There's always an economical aspect to it. So first, let's understand what's closed source and what's open source. Open source not necessarily means it's free. Not everything that's open source is free. So there are different kinds of licenses, right? Hey, you can use this, but not beyond this limit. You can use this, but if you make this change, you have to show this also, right? There are different classes of licenses. The one of the biggest confusion is open source is always free. No, open source means your source is open. You can go inspect it, and then there are different levels to how much is it open, right? Now the things with OpenAI and all this it's completely closed source. Like you call my API, you use it, you pay me. That's all you know about it, and that's all you can know about it, right? If I feel like it, I'll publish a paper. Like that's the whole idea over there. Now, the argument that one could make is everything is an economical opportunity. So there is no arguing the fact that Google owned search for the past couple of decades. They literally owned it, which means you cannot compete with Google if you're building a business around search. It's just not going to happen. And with more capital and more talent and more distribution, they kept on making their search business so well that it was just a monopoly at one point, right? Same with social media and Meta. So each of these big tech had certain areas. And today, if you see, make no mistake, big tech owns AI at this point, right? It's just plain front and center. But the idea is there's still not one big king of the whole space. And the idea is if you can own AI, you would have a monopoly unlike any other. It's an asymmetrical force, which means you're going to do anything and everything to stop others also from having that monopoly, right? Not just build your own. So, what can stop a monopoly in this space? Because this field is so raw. Because this field is so raw, a lot of concepts need to be translated, new concepts need to be created. So, a lot of experimentation will be required. It's not going to happen one day. And no one company can do it. So, open source has really thrived at getting the community together and sharing the benefits with the community. That has always happened. So Hugging Face kind of created this GitHub for AI, and they're like, you know what, you guys gonna start sharing your data, start sharing your models. I'm gonna create a centralized leaderboard. Everyone can participate. Everyone can fork each other's model. That actually brought down the barrier to entry in this whole AI space for new incumbents, right? Because in the end, AI is a problem of data, capital, and talent. If you have three, then all you need is distribution to iterate it faster. Now, these four items are, a monopoly of big tech. So it was a point of bringing that barrier down. This is where companies like, again, this part is pure speculation and everyone can have their own opinion, but I do feel like Meta has not rolled out Llama in the goodwill of their heart. Like right now, open source is just good business strategy in AI. Like if you do things in open source, community is gonna test it for you. The odds of you creating something that beats something else is gonna increase. It's gonna give you more distribution, reach, and adoption. So the idea is, I I'm a bit skeptical on this whole point that when a corporate does something open source, they're doing it out of goodness of their heart. If they are good for them, good karma. But otherwise, open source is the new favorite word of the day for every company, and everyone has their selfish motives around it. But that's not the soul of open source, right? So the entire internet is built on the foundation. Like the entire spirit of internet is open source. HTTP, www, and then you have this idea of Git. All of these things, they are open source. Linux, open source, right? Came out of Unix, all of those things. The entire world was like all of these data centers and servers use Linux to run it. So it's one of those things. You are rooting for the underdog, or are you trying to take advantage of the underdog? Is there a selfish motive to it? So this answer is purely speculative, and it opens a lot of conspiracy theories and all those things.
Got it. Sure, we will see a lot of evolution on the open source side. We've already seen a bunch of different technologies that were previously open source were taken closed source. So I'm sure some of that phenomenon is also going to happen in this ecosystem. All right. Talk about co-pilots a little bit. right? Companies are creating text, image, videos, or you can say every SaaS solution has a co-pilot, whether it's good or bad. I think that's questionable, but they are trying to make sure that they don't fall behind in this whole AI race and has at least one AI companion that they can put out to their customer. I'm pretty sure there are a ton of challenges to really operationalize these co-pilots, and even more so to perhaps improve them to a level where you can really start charging something meaningful from these co-pilots. Can you talk about what are you seeing in terms of issues that these companies who are building AI solutions to put in front of their users are facing?
So I think building a co-pilot is good way, right? The whole idea is you want to make things simple. You want to cut through all the steps, and AI helps you do that, and you can create rich journeys. Good. The challenge comes in when you're building any sort of a co-pilot system. You pretty much have only two ways to go about it, right? Either you kind of invoke an LLM directly, make an API call to that LLM, and kind of make that model, not LLM, any kind of a system that you want to use, and just make it really strong enough, right? You go deep into the AI, fine tune it, optimize it, work on it, and just put it for your use case, right? And make an API call to that. Or you create like an agentic OS kind of a structure, agents, RAG, LLM being invoked at different steps, looking up certain database so that you can get some resemblance of controllability, right? And then your customer essentially talks to this entire system that you have created instead of them talking directly to your model. These are the only two ways. Now, in either of these two ways, what you can do is you can either use a closed source system like OpenAI, right? Or you can create a your own model, or let's say you can take any open source model and build on top of it. Right? So two approaches, either go closed source or open source, where the model needs to be called, and two approaches. So if you're going on the closed source approach, right, that's the best way to start. If you're starting it, because there's not a lot of complexity to it. You simply make an API call, get the output, done with it, right? To get it started. But once you really want to make it like a production grade system, get some quality output from it, behave it in a certain way, the only option you have is you want to create some sort of an agentic framework, some RAG mechanisms around it, and then probably host your own model somewhere, right? Because you need to have control of your weight so that you can understand, optimize, and improve those systems. This is where all of those challenges that I described above, right? Yeah, challenge with controllability, challenge with interpretability, challenge with determinism, the challenge with decomposability. After a certain point, you'll see them at your face. So you can get from 0 to 80 like this. That's the whole idea with these generative AI systems, right? You get a demo of something out very fast. Now, once you want to go from that 80 to 100, that long tail problem space that your model needs to be really wary of. Hey, in this scenario, don't behave this way. This scenario, don't behave this way. The challenge is you don't have tools to solve that problem. If you have tools to solve that problem, they're still research problems. And if they are solving it, they don't solve it completely, right? And that is where most of these companies struggle. So we have been onboarding a few pilots at DAO Studio to use our product YOJN, and we have been talking to a lot of customers. And almost every conversation, the conversation always ends with these points only. Hey, how do I make a call to this area? And the answer is you can't. Okay, how do I go about doing this better? How do I make sure my model never gives these things? And then the idea is there are 100 tools. Now you need to take this one, stitch them together. But this tool is also evolving on its own. This is what. So it's a circus at that point, because now you are pushing the boundaries of engineering at that point, right? Because you have taken something that was a research item for the good part of the century and only became something like a production grade in the past 1 2 years, and just all of a sudden put it into production because everyone's doing it. But now you don't have that kind of system that controls this engineering output. So now you have to push the boundaries of engineering to actually create those systems and make them work in a similar way. Or what would you do? You'd say, okay, I'll have all the best AI talent on the planet. Right? That doesn't really work well, right? It's an HR problem after that. So how do you solve about these problems? You need to take the existing workforce with the existing software analogies. You need to solve these problems one by one. That's where the tools and technologies and systems are really lacking. We're pushing the boundaries of what is known. And that's where these companies get stuck. Okay, you can get to that demo really nice, and your board is happy. Investors say, oh, wow, very nice. But when it comes to taking to customers, it's almost a quarter away for past 2 years.
Interesting. So you have a product, YOJN.ai, right, which enables enterprises to deploy, improve, and manage their AI at scale. Tell us more about it and if that is really tackling any of the problems with these companies who are building their own AI solutions.
DAO Studio, when we created YOJN, our thought was very straightforward. No company can possibly hire all AI talent on this planet. You're going to need your business team, you're going to need your subject matter expert, you're going to need your product teams to solve that problem. There's just no way around it, right? Of course, your software teams would help. Of course, your AI team would help. But there's not enough AI talent on this planet to work just for one company, right? So, first thing was we need to make things simple. Simple enough for subject matter experts to understand what's happening inside the model, not for AI experts. The second thing was give a shared vocabulary to AI experts and subject matter experts to improve this system because it's going to be a collaborative effort. So, around those lines, we created a system that works really well with these agentic systems where you can create these agents, you can do RAG, and you can deploy a model. But where we actually differed was we said, even after all of these things, these agents are really dumb because they just come alive at one particular moment and then they're calling an LLM and then LLM is doing all the job and there's no idea of retry functionality. You don't know where the model has taken the step and it cannot go backtrack its step. So our core work was just making that one functionality really better. Can my agents become self-learning? Can my agents become as smart as possible? Can they become more state aware? All of this fancy work is being done to solve only one problem. Can I get surety of my output? Right. So there are a lot of things we do around it. We also work on the fine tuning part of it. Okay, once we can kind of understand how the model has behaved, can we show it in a very simple way to a user? And a subject matter expert can give a feedback at that one particular step only where he thought the model went wrong. So that we can increase the context going in and reduce the garbage going inside the model, right? The first principle, that's where our focus is. Just to do that one small thing, we had to do a ton of things, but that's all it did. And then came the whole fine tuning part that, okay, if it can do this, can I kind of create different snapshots of it? Can I create different variations of it? And can I compare them in simple 1 to 2 clicks? I don't need to understand all these fancy, complicated maths. Just teach to me like a 5-year-old, right? So that was the focus of creating that whole fine tuning part of the system. And then came the whole idea, if you want to increase the adoption of these systems for these companies to make AI better, then we need to talk in the same language their software teams talk. So we started working around the deployment piece. Okay, we'll do Kubernetes, we'll do this AWS deployment, we'll give you self-hosted, all of those things, right? So essentially what we're trying to do is we're trying to solve these three fundamental problems: controllability, explainability, and decomposability. And in doing so, what we're trying to do is we're trying to take the fundamental principles of software engineering and we're trying to apply it into AI so that teams can work together the way they used to build SaaS, right? Kind of like how in Mixpanel, the product team can simply see what are my DAO, MAO, and all those metrics, and then you can take better business decision through segment. You don't constantly need to engage a software engineering team, and you can get like a data representation codes one way, so that your operation and growth experts can analyze that data. And then your engineering team, with 2-3 clicks, they can kind of work on integrating these systems and then focus really on the reliability part and software engineering part and scalability part of these things. And that's what we wanted these AI systems to do, because once we can do that, then we can do some sort of determinism, some sort of controllability, some sort of explainability, and some sort of decomposability. And that kind of moves the needle beyond that 80%, right? So a lot of things have to come together, and that's what we focused on building in YOJN.
Got it. So it's essentially an AI engine that you can deploy at scale?
From a marketing point of view, we can say that. From an engineering point of view, I don't want to tip off the engineering community, so I'm not going to say that.
Fair. So look, the audience are again mostly finance folks
Here.
here. What you said all makes sense, but is there any direct benefit of YOJN to the CFOs or finance folks here? Is there some cost element? Like why, if I'm a CFO of a company where, let's say you are coming into my engineering team, my AI team to deploy YOJN, why should I be interested in deploying YOJN or having my teams work with YOJN rather than all the other crazy things that they may be doing?
Yes, so there are two ways that you could use Fusion. You could either use Fusion to make your work better, right? Or you could use Fusion to make sure whatever your team's doing, you can get transparent in terms of the pricing and the growth of that system. So what I mean by that is, as a CFO, it's really important for you guys to be able to model the cost and the return from that cost, right? The ROIs really matter, right? You can't be burning billions of dollars and not generating revenue after a certain point. So you really need to know, hey, these are the steps that were taken for my model, and it gave me growth in this one particular area with this amount of compute, right? So you need that visibility. On the second hand, you want certain kind of controllability on that visibility as well, right? So, for example, with most of these tools, there's a lot of voodoo token economics going on, right? Okay, after these many tokens, you get charged this much. Around these many API calls, you get charged this much. Well, see, that's all an attempt to kind of make the pricing less transparent, more opaque. And we don't believe in that. Our idea is very straightforward. The product should kind of justify the cost in itself. So once we kind of partner with you, we simply tell you, hey, this is the fixed cost. That's all you need to pay. Now you make a million call, trillion call. That's up to you. We're not going to keep charging you for each and every nonsense thing. It's your job to iteratively grow. So you're going to do multiple experiments. You're going to scale it to multiple people. I'm not going to keep on charging you for all of those unnecessary things. I've built my business in such a way that I can still survive. Now, the second aspect to it is we offer this thing called self-hosting, right? Which means you don't have to worry about building all of those engineering processes and cost heads around, hosting your own model. Which means once you do host it in your infrastructure, what you're essentially paying for is the cost of that EC2 machine. Let's say you hosted it on like a GPU instance of an EC2 on AWS. So now you know it's going to cost you $1.75 per hour. Now it's up to my kind of engineering team how they want to scale it up. They're using Kubernetes, they'll scale it to 5 systems. So okay, 5 times it will cost me that much. All of those things. But it's still clear. So as a CFO, it would help you get a better modeling of the cost, and then you can kind of decide for yourself, hey, with this cost, this much is how my model has grown in this area. We do offer direct A/B testing, right? So then it makes it easy for you to make that build versus buy versus drop versus push kind of calls.
Super interesting. So actually have a budget on your AI application development, AI experimentation, rather than sanctioning a lump sum amount of X millions on which you may have no idea at all in terms of what kind of returns could be expected. It might give amazing returns, or it might suck all of that up and still be pretty crappy in terms of the responses that your AI application is actually giving, or any other usage that your AI application is used for.
Yeah,
Super interesting.
because see, the whole idea is you're not going to create a good AI system in one day, right? Let's first accept the fact it's going to be an iterative approach. Your entire business would need to be involved because it's not just a research problem. It's a business problem in the end, right? That means you're going to iterate it. So you have to solve for how do you survive and how do you grow responsibly. Budgeting will be a core part of your AI strategy.
Do you see? So this is a new challenge in itself, and I'm not just talking about cost. I'm talking about coming up or creating AI applications on its own. Do you see optional changes to really make this whole thing efficient? Because previously there was a product management team involved with a development team with some inputs coming from the front line, right? People who would touch customers on a regular basis. And that would more or less be enough to create a software product, iterate on it, so on and so forth. And there was always a lack, right? Or there was always a complaint that, hey, there's a lack of customer interaction for these PMs and for these engineers to really understand what's going on, right? And there is kind of some context lost in communication. In some ways, with AI applications, it is much more the case. AI applications are all about the context. If the context is gone, again, it's just like complete garbage in, garbage out. And so, as you said, the subject matter experts or the business folks need to be much more integrally involved. Plus, you have this new AI engineer, maybe AI product manager as two other constituents, right? And plus maybe the finance team who really cares about how much of a money you might end up blowing up in this experimentative product that you are creating. Do you foresee an organizational change? I'm sure that it's an emerging factor as well. Not many people would have figured out what's the best way to make it work. But is there an organizational change in the works where there is a better way to manage this craziness across the multiple disciplines that it needs to touch to make it happen?
Yeah, so I think we need to kind of demystify the whole idea of AI. Right now, everyone's talking about AI as if it's this one magical beast from fantasy world. But you have to realize it's a branch of mathematics and software engineering in the end. So your organization need not become completely different organization. You just really need to be very clear on what you want to achieve from this AI, what are you willing to put in to achieve this AI, and what resources do you have available to get to that point. As long as you have that clarity, your software engineers and your product managers and your business folks and your finance folks can work together to create AI in a very similar way. I'll give you a simple example. So in typical SaaS world, what do? You A/B test your UI. Why? Because you want to improve your customer experience and push the adoption in a particular direction that favors the business goal. That's what you do. Okay. What is user experience in an AI product? It's the perception of intelligence for the domain the customer is asking intelligence for, right? From that model. So essentially, here also your product managers will do A/B testing. The difference is they'll A/B test the quality of response getting out of it. So does that mean you need AI product manager? I would argue no. Let's not blow things out of water, right? You still have to do A/B testing in the end, right? Okay, you had DevOps team that used to scale your systems to millions of users, right? Here also you're gonna scale it to millions of users, right? The endpoint still will be scaled. So do you need AI DevOps team? Arguably no. You need DevOps team, but with a bit more clarity on what do you want this particular piece of software to scale to. Because AI arguably in the end is still that piece of software. Completely new kinds of architecture, amazing work, awesome work by the community. But still, in terms of the whole business aspect, it's the same thing. Which essentially brings you back to the business team. In a SaaS world, like if your business team constantly say, hey, today I want to go this direction, tomorrow I want to go this direction, what will your product teams be able to do if they don't have that level of autonomy, right? It doesn't work that way. Similarly, a business team still needs to be involved in terms of what do they want from their customers and their businesses so that their product teams can build those kind of AIs, right? So I would say the alignment is still there. What's happening right now, the biggest challenge is everyone kind of sees AI as this weird fantasy beast. Okay, get some AI product managers, AI researcher, AI scientists in my company and give them this problem, they'll solve this. How do you want to do this? I probably cannot tell you. Okay, then how do you expect me to do this, right? That's the barrier that needs to be broken down. And we need to kind of humanize it back again to the standards of engineering practices. So over there also you had finance budgets. You'll have finance budgets in AI. You had deployment targets you'll have here. Today with AI, most people don't use OKRs the way they should be using, right? In SaaS, you have OKRs. hey, I want to grow my adoption to this much for this segment. What's your OKR for your AI team, right? No one has a clue to solve those problems. These are the fundamental problems we need to be focusing on instead of saying, okay, get me more AI scientists in my team and create this new model. That it doesn't work.
Awesome. Any predictions about AI? We going like we have almost half of 2024 is gone, so for the rest of 2024 or for 2025.
The AI prediction space is so weird because anything you say will be held up against you in the court of law. It's kind of the Miranda rights thing happening with it, right? And it's very non-linear. You cannot predict anything. But on a meta level, I see one trend. Today we are in 8086 era of AI, no doubt about it, right? So if you look at how the entire computer architecture and software evolved, back in the day, Intel came up with this architecture 8086 series of microprocessors, right? Very small controllers, like KBs of RAMs, and that's the dimension we were talking about. So at that time, there were different kinds of software challenges, like even with the games like Mario that you used to see and all these console games, right? At that time, the programmers wrote some really memory efficient code to even hide some pieces of information and game levels inside of those pixels that you see over there, right? It was really efficient design. Now, as these systems became bigger, more efficient over the time, today, I would say like the Apple logo takes more memory than an entire OS used to take back then. So we have to be cognizant of the way systems evolve, and a lot of those problems that we were solving at that time don't even matter today. Similarly, a lot of the problems that we as a community are focused on solving, oh, we need to solve this, probably will not matter when you kind of look back 5-10 years down the line because the capacity of these systems are so huge. I mean, think about 1000x bigger system with, let's say, 10,000 times bigger context windows, right? Because see, if you have petabytes of data, then probably RAG would still matter for you. But if your data could fit inside that one context window, and you have a model which is like 100 times bigger size and 100 times lesser compute, then probably most of the problems that you're trying to solve for with this architecture are already solved for with that system. Right? So it will evolve in very weird ways, and energy and compute footprints are going to be key aspects of it, right? Because we are in the early stages. And as these systems evolve, there will be a continuous focus on reliability because now, any technology has that hype curve and then valley of realization. So I see AI will kind of start entering in that space where people will realize, okay, we need to build better QA systems around these things so we can actually really take advantage of it. We need to build better business processes that can take advantage of it. And we want AI to observe more of our business so that AI can kind of learn from it, but we want more explainability from this AI so that we can performance review what it has learned, and then it can kind of be put into production. That I see that going to evolve, and somewhere down the line, I think we would come to a point where the fundamental intelligence inside of these models are being localized and commoditized. That's when we will see real AI native architectures being built.
Awesome. That's interesting. Democratizing intelligence, right? Well, we'll move to our lightning round on that note. It should be simple, fun round where I'm going to ask you some quick questions and I need immediate responses. So let's start. Sweet or savory? What do you prefer?
Wait,
Books or podcasts?
books,
Thinker or doer?
doer,
Introvert or extrovert?
introvert,
How does someone impress you?
staying consistent,
If not an AI builder, what would you be?
hermit.
What's you could teleport yourself right now?
Okay.
Where would you go and why?
Where would I go and why? I'll probably go to Mars and see life in a very different way.
Number one item on your bucket list, other than going to Mars.
1 year long sabbatical.
Didn't you just start your company? If you could uninvent something, what would it be?
Technology.
That's quite a large body of work to uninvent.
How would I kind of go back and undo Maxwell's equation?
All right. Who's your role model, personally or professionally?
Oh, personally, it's the Swami Vivekananda. So I am really inspired by this one thing where he said, Give me 100 people who are truly dedicated, and I'll change the nation. And I think that really matters because if you have that focused team, you can do anything, right?
Awesome. One thing that can make you 10 times more productive.
And AGI, that is my personal butler.
All right. The last one. Describe yourself in 3 words.
Creative, goofy, consistent.
All right. Well, Lars, this has been an amazing show. Thank you for demystifying artificial intelligence for us. Really appreciate all the thoughts that you've shared.
Thank you, Rohit.